focused more on mobile IP network authentication and registration key generation. And really, this is any time we have to do roaming across multiple layer 3 boundaries. It uses what's known as the GSM subscriber identity module. Now, the rationale for using the GSM subscriber identity module with mobile IP is to leverage the existing GSM authorization infrastructure with our existing user base and the existing SIM card distribution channels. By using SIM key exchange, no other pre-configured security association besides the SIM card is required on the mobile node. The idea is to not use the GSM radio access technology, but to use GSM SIM authorization with mobile IP over any link layer. And one good example of that is for wireless LAN access networks. It's likely that this list of authentication types will also continue to grow. Most vendors are brutally competitive when it comes to implementing their own versions of extensible authentication protocols, which are specifically focused on talking to their back-end authentication servers. What we've got to figure out is what is going to be decided upon as a standard. We may have several different options given to us, even by our preferred vendor. The last of our security solutions that we're going to focus on is a VPN solution. Now, with VPN solutions, we're really talking about the ability to securely transmit data between two network devices over an unsecure transport medium. It's commonly used to link remote computers to networks that exist across the internet because the internet is deemed to be so unsecure. However, VPN is an excellent solution for protecting data on a wireless network. VPN will work by creating a tunnel on top of a protocol such as IP. Traffic inside the tunnel is always encrypted or can be encrypted depending upon your needs and totally isolated from all other traffic patterns. VPN technology provides 3 non-exclusive levels of security: user authentication, encryption, and data authentication as well, such as integrity and source authentication to guarantee that packet data is not mishandled during transit. User authentication ensures that only users over a specified device are able to connect, send, and receive data over a given network, such as our wireless LAN. Encryption offers additional protection as it ensures that even if transmissions are intercepted, the only data in the payload is ciphertext, and it cannot be decoded without significant time and effort. In addition, data authentication ensures the integrity of data on the network, guaranteeing that all traffic is from an authenticated device only. Applying this type of technology to a secure wireless network does require a much different approach than when used on wired networks, however. And one of the options that's my favorite is actually being able to do auto-initialization of VPN connectivity based upon IP addresses that might be obtained over a wireless network. Some of the more advanced vendor solutions actually offer auto-initiation features where when an IP address is obtained from a given network range, a VPN connection can automatically be established. Thus, if anybody ever connects to a wireless LAN and gets an IP address from the wireless LAN network range, automatically they'll create a VPN connection to the VPN server. The beauty of that is that we can completely lock down all of our wireless communications. Another function that you have to look at with VPN is the inherent repeater function of wireless access points, which automatically forward traffic between wireless LAN stations that communicate together and that appear on the same wireless network. The range of the wireless network will likely extend beyond the physical boundaries of an office or a home, giving intruders the means to compromise the network. The ease and scalability with which our wireless LAN solutions can currently be deployed makes them ideal solutions for a lot of different environments. But as a result, it's really going to make our VPN security vary from network to network based upon the needs of each environment. A really good example of this is that if a hacker had a wireless protocol analyzer and obtained the web key somehow on your wireless network, they would be able to decode packets in real time. However, with a VPN solution, not only would the packets be encrypted, but they would also be virtually tunneled. And that means that this extra layer of protection is going to provide you a tremendous amount of benefit. If the attacker actually received this data, all of the data would be ciphertext, and it would have to be decrypted using a very extensive period of time and a lot of processing power. One important note is roaming with VPNs. You have to consider that not all VPN connection options will allow a user to roam between subnets or networks without actually breaking the secure tunnel. And not all VPNs will permit transport and application connections to remain established during roaming. Another stumbling block is the operating system. It's got to support mobile clients. It's got to support this type of protection. It's also got to support VPN. So you need to consider with a VPN solution, you do have some legwork to do. You really need to understand what your systems, your hardware, and what your network is capable of before deciding upon it for a solution. VPN, definitely a good idea, but also a good idea to learn as much about it as you possibly can. If you're dealing with IP VPNs, the best thing that you can use is IPsec, as it does support some of the more advanced crypto standards like Advanced Encryption Standard or AES. Those are great ways to go. Really, the objective here is understanding the two major parts of a client's connection, authentication and association, and then being able to help secure those initial management frames that are used for the purposes of doing so can really help to secure your overall network solution. Your LAN client has a connection to your wireless network, and now they start to move around. What's actually going to happen as they move? This is one of the things that's very important about understanding service sets, understanding roaming, and understanding reassociation when the client actually moves their position in the wireless network. A service set is a term that's used to describe the basic components of a fully operational wireless LAN. In other words, there's 3 ways to configure a wireless LAN, and each way requires a different set of hardware. We have the basic service set, the extended service set, and the independent basic service set, or IBSS. The basic service set is where one wireless access point is connected to a wired network and a set of wireless stations. The network configuration is referred to as a basic service set. Basic service sets consist of only one access point and up to many wireless clients. A basic service set uses only what is known as infrastructure mode, a mode that requires use of an access point and in which all of the wireless traffic has to traverse that access point. No direct client-to-client transmissions are allowed. Each wireless client must use the access point to communicate with any other wireless client or any wired host on the network. The basic service set covers a single cell or a single RF area around the access point with varying data rate zones, concentric circles, of different data speeds that are all measured in megabits per second. The data speeds in these concentric circles will depend upon the technology that's being utilized or what standard of 802.11 you happen to be using. If the BSS was made up of 802.11b hardware equipment, then the concentric circles would have data speeds of 11, 5.5, 2, and 1 megabits per second. The data rates get smaller as the circles get farther away from the access point. A basic service set has a single unique SSID. Now this does differ quite a bit from an extended service set. An extended service set is defined as 2 or more basic service sets connected by a common distribution system. The distribution system can either be wired, wireless, LAN, WAN, or any other method of network connectivity. An extended service set must have at least 2 access points operating in infrastructure mode. Similar to a BSS, all packets in an extended service set must go through one of those access points. Other characteristics of extended service sets exist, according to the 802.11 standard, that are an ESS covers multiple cells and so forth, but it does not require roaming capabilities and it does not require the same SSID in both service sets. The final service set is known as the independent basic service set. This is also known as an ad hoc network. An IBSS has no access point or any other access to a distribution system, but covers a single cell and has one SSID. The clients in an IBSS alternate the responsibility of sending beacons since there is no access point to perform this task. In order to transmit data outside of an independent basic service set, one of the clients must be acting as a gateway or router using a software solution for this purpose. In an IBSS, clients make direct connections to each other. And because they do so, they transmit data direct to each client. For this reason, IBSS is often referred to as a peer-to-peer network. Now, if you were to quantify these 3 service set types and identify when you would use each one, obviously basic and extended are pretty straightforward. But why would you have an ad hoc network? An ad hoc network is normally used anytime you do not have an access point, but you do have devices that are capable client devices that are capable of creating an ad hoc wireless network. They will actually use their wireless antenna to be able to allow other stations to connect to them. they become a peer-to-peer network, and it makes it very easy to have wireless access anytime you have a bunch of wireless